All right, in this video, we're going to go through several examples using set notation, okay? So the sample space, S, is the entire number line, all right? Just want to point out that S, sometimes you will see that referred to as omega, all right? So they're the entire sample space. And then we have events B, C, A, B, and C, which are listed here, all right? So the first thing we want to do is we want to find A complement. Complement means not in A, all right? Sometimes you will see this written as A prime. That's the same thing. All right, so I think it's always easier to kind of draw this out. Let's start with what is A. A is, we start at 1 and then we go to 4. X such that X is between 1 and 4, and we include 1 and 4. So here is A. All right. So what's not in A? What's the complement of A? Right? Since the sample space is the entire number line, it basically would be everywhere else on the number line except for where A is. Okay. So here's A, and then everywhere else, that's where the complement is. Okay. So this equals X such that X is less than 1 or X is more than 4. Okay? And we don't include 1 or 4 because 1 and 4 are included in A. All right, next we have union. All right, what does union mean? All right, let's just go and write this down here. Union means or. All right. Union means the elements are part of A or B. All right. So let's draw this out. Let's start with drawing out A. A is from 1 to 4. All right. Including 1 and 4. Here's A. Okay. And B is between 2 and 6, not including 2, but yes, including 6. Okay. So now if we want to be part of A or B, then we'd start at 1, we go all the way to 4, right? We get picked up by B, and then we go all the way to 6. Okay. So here's B. So if we're part of A or B, then basically we're between, this is equal to X, such that X is between 1, includes 1. Okay, we get picked up at 1, and then we don't get dropped off until we get to 6. And we include 6. Okay? So all the elements that are in either A or B is from 1 all the way till I get to 6. All right. Now moving on to the next question, we have B intersection C. All right. So I didn't write the intersection. Intersection is like an upside down U. Okay. Times C complement. So B intersection C complement, right? So this guy intersection means and. Right? And a lot of times we don't write the intersection symbol because it's just kind of assumed to be there. And statisticians, just like mathematicians, are lazy in their notation. And, we just basically, we assume that intersection is known to be there when you have two events that are written next to each other like that. Okay? So since these are sets, this is not multiplication, right? We are talking about the intersection between B and C complement. All right. So intersection means and. All right. So let's start with B. Let's draw out where B is. So we have 2 until I get to 6. Include 6. Don't include 2. All right. So this is where B is. What about C complement? Well, C is less than 0. Right. So less than or equal to 0. So this is C. So where C complement would be more than 0. All right? So if this is 0, this is C complement, more than 0. Okay? So now we want to be intersecting B and C complement. So that means we need elements that belong to both B and C complement. All right? If I start here at 0, I don't belong to both. Right? I only belong to C complement. I don't start belonging to both until I get to 2. All right? I belong to both until I get to 6. And then I stop belonging to both, right? So this equals X such that X is between 2, not including 2, and 6. And I do include 6. Right? And if we notice that that is exactly what B is. So this equals B. All right? All right, getting a little more complicated, but we can take it slowly. All right? A complement, B complement, C complement. So now I have 3 events, and I'm talking about the intersection between these 3 events, right? Even though it's not written, we know that we assume that this means A complement intersection, B complement intersection, C complement. All right? So let's start by writing A, and then I'll write B, and then I'll write C. Okay? So A complement. Okay, so here's A at 1 to 4. This is where A is, 1 to 4. So the complement of A would be less than 1 and more than 4. Okay, now let's do B complement. So B is from 2 to 6. Open parenthesis on open dot at 2, close at 6. Okay, so this is where B is. So B complement, let me change colors, is less than 2 and open dot more than 6. Close dot at 2. Okay, and then lastly C. C is less than 0. So here's 0, less than or equal to 0. So then the complement would be open circle at 0 and more than 0. Okay, so I'm looking for elements that belong to all 3 of these. Right? So I'd have to, so anything less than 0 doesn't belong to C complement. So I can go ahead and knock that out. Until I get to 0, now I start having elements that belong to all 3. Right? I belong to all 3 until I get to 1. Okay, so my answer is going to be equals X, such that X is between 1 or 0 and 1, right? And I do not include 1 because it's the complement of A, and A includes 1. And I do not include 0 because it's the complement of C, and C includes 0. Okay, so between 0 and 1. Or, let's see if I continue looking. Here I do not belong to A complement, do not belong to A complement, I do not belong to B complement. Until I get over here, now I start belonging to all 3 again. Okay, so I belong to all 3 here, and I belong to all 3 here. What's going on here? This is 6 onward, right? So basically, if X is more than 6, let me write that the other way around. Usually we tend to write that as X is more than 6, right? And I don't include 6 because that's not part of B complement. So strictly more than. Okay? All right, last example for this video. A union B intersection with C. So always start with what's inside the parentheses. Okay? So let's start by writing out what is A. All right. So A is between 1 and 4. Closed on both. Okay? So this is A. B is between 2, open at 2, closed at 6. Okay, so the union between A and B, so union means or, so if I belong to either or, right? So the union, let me scroll down, I'm gonna write the union first, okay? So the union would be 1, starting at 1, close that dot, all the way until I get to 6, close that dot at 6. So right here, this is A union B, okay? So that's where the elements belong to A or they belong to B. All right, then I want to intersect that with C. So C is less than 0. So here is 0, closed, and less than. Okay, so remember what is C? C means and. So I'm looking for elements that belong to both C and A union B. All right, are there any elements that belong to both of those? No, right? Because C is down here and B is up here, right? There are no elements that belong to both A union B and C. Okay, so that would be the empty set, which is written as a circle with a slash through it, or sometimes you'll see that written like that, empty set. All right, thanks for watching.